great start. We're going to hear from Dr. Janel Hanrahan, and to introduce her is my colleague and really the driver of this conference, Thais Carter. She coordinates our communications and strategic initiatives, and even down to little details like the amazing food that was in the lobby from Roots Organic Juice Cafe, which you must have if you haven't had some already. Thais is there from the big to the little and brings it all together. So please welcome Thais Carter.
I do not want to take a moment away from Dr. Hanrahan's presentation. So I'm not going to read her full biography to you because you have it in your program. And if you don't have a program, raise your hand. We will have one hand delivered to you in your seat. Over here. What I really want to do is use this opportunity to talk to you a little bit about why we chose Dr. Hanrahan. She's the Assistant Professor of Atmospheric Sciences at Lyndon State College. Her research has included the investigation of the impacts of anthropogenic climate change on the Great Lakes water levels, intense rainfall in the Canadian prairies, and weather patterns around New England. But the thing that set her apart when we were trying to find someone to kick off the event today is the fact that in 2017, she had helped to lead a town hall on how to make climate change a national priority. And she did this at the American Meteorological Society's annual meeting. And the thing that I love is that this is not a conversation that she has kind of only had with her colleagues in the meteorological community. What I love is that this is also something that is infused in her classroom with her students, that this is something that she is taking out into the community that she's a part of, speaking at local math conferences and at K-12 schools, that in all that she does, she's not content to keep it just within the classroom or just within research, that she is constantly pushing those that she works with and those that she is educating to think about how we can take this information and make it accessible and understandable to citizens who are not actively studying the science behind all of these things, because she understands that part of making the changes necessary to face these environmental challenges is making sure that everyday citizens understand what's going on, feel invested in that change, and are part of raising their voices for why we need to do something. So I can think of no better person to kick things off for us this morning than Dr. Janel Hanrahan. Please join me in welcoming her.
Good morning. How's everyone doing this morning? Good? So, tired? Some of you may be on your phones already. I know there's a lot of students in here, so you may be. But I'm actually going to encourage you to take your phones out, so if you don't have it out already, please do that. And what you're going to do is go to this URL right here. So it's polev.com / my first name, Janel, Janel. They couldn't fit my last name, so Hanrahan 092. Apparently there are 91 others. And when you get there, you'll be invited to enter a username. If you want to do that, you can. Otherwise, you can just click skip, and then you'll get to a blue screen that says welcome to my presentation. Technology and this sort of thing always makes me nervous, because if it works well, it works great, but if it doesn't work well, then we gotta figure something else out. So maybe if I could just get a nod when someone gets to a blue screen that says that they're at my presentation. It says it can't be loaded. Does anyone else have that?
You have to retype the URL.
Maybe retype the URL. Let's try. Okay, so you have a little bit of time. So okay, good. So I'm getting some nods. Okay, great. So what I'm going to do this morning, and we're going to start out with an activity, okay? But what I want to preface this with is that at no time is there actually a fire in this room, okay? So I just want to tell you that please don't get up and go running out of the room screaming. There's no fire in this room, okay? But we're going to start out with a scenario where, and by the way, if you haven't gotten here yet, the URL is still down here if you need it. So we're going to start out with the following scenario. So somebody in the back of the room, maybe over there, stands up and actually states that there's a fire in the back of the room. Okay, so what I want you to do is I want you to maybe even close your eyes and think about this scenario and what you might do if this were actually happening right now. Okay, so kind of think about this playing out. So think about if somebody just stood up in the back of the room and said that there's a fire. But it's going to get a little more complicated. So you don't actually see the fire, and you don't smell the smoke. Okay, so right now all you know is that somebody just stood up and yelled that there's a fire in the back of the room. Ignore the fact that there's a fire extinguisher on that back wall. And please don't pull the fire tab over there. But let's just say there's no fire extinguisher or water source nearby. So there's no obvious way that we can put this fire out. No one can leave. I'm not going to tell you why. It's just nobody can leave. Okay? So we're stuck with this situation. There may or may not be a fire in the back of the room, but according to this individual right now, there is no obvious way to take care of this. We can't go anywhere. There's kids in the other room. So when I was putting this together, I was thinking, well, I could be on that side of the room or I could be on that side of the room, but little did I know I would be surrounded by windows. So let's say that the kids are maybe back in that area, okay? So we have children that are in the other room. So my question for you is, what do you do? So I want you to just think about this for a minute. What might you do if this were the scenario? This is where the magic starts to happen, hopefully. So the question is, what do you do? And so I'm going to actually give you 5 possibilities. You can look for a way to put it out. Even though it's not obvious, you're going to look for a way to put it out. Good, 2 results so far. Open the windows. We may want to do that if the room is starting to fill with smoke or something like that, just to kind of buy us some time, right? So we could open the windows. We could ask for more information, try to figure out what's happening. We could watch an amusement. Maybe you're that type of person, you just want to watch and see everything play out. Or you could just cover your ears and sing loudly and just decide, no, I'm going to completely and totally disengage from this situation. So let's see, we have 41 results so far. Okay. So we'll let the rest of them come in. And what you'll notice is that after you've entered this, if you scroll down, so no one wants to open the windows, okay. So when you scroll down, you can see. Thank you for that, whoever that was. When you scroll down, you can see that you can clear your result and then you can change your answer. And so what I want to do is actually encourage you to do that as we go through this, okay? So right now, it looks like most of the people in this room, so 60% of you are saying, we're going to figure out a way to put this out. We need to hurry up and try to tackle this, right? A few of you are like, okay, I'm going to try to get a little bit more information. Someone else now stands up, maybe over here. There's no fire, you're nuts. What are you talking about? Remind you that you can change your answer if you want. Someone else stands up. Well, it's a new kind of fire. It's invisible. It's still really, really dangerous, okay? So it's still going to spread. It's still going to destroy everything. It could potentially burn down the entire building. The smoke will asphyxiate us. So it's still really dangerous, but it's invisible. Okay, some people are starting to watch an amusement. There's no such thing. This is ridiculous. But I am an expert, okay? If we leave this, if we don't do something about it, the results may be catastrophic. Now someone actually smells smoke. So we still don't see it, but somebody says now that they're actually starting to see evidence of this. Where are we at here? Still looking for a way to put it out. Lots of people asking for more information. That's going down. Okay, open the windows. All right, now we have a few people who are going to start opening the windows. You are an alarmist. Stop trying to scare everyone. Shouldn't we at least open the windows? Might be a good thing to do if we can't leave. Okay, we have more people opening the windows now. A few watching in amusement. No, that's exactly what they want you to do. They're going to let all the burglars in. Okay, I've been robbed before, and in fact, what I think is that some of these alarmists might actually be in on this. I think that they're going to try to steal your money, they're going to take your wallets and your purses, and they're actually in on this, and they're actually going to benefit from this, because then they're going to get a cut of this money. So don't open the windows, because all these burglars are going to start to come in. Fewer people are now opening the windows. There are no burglars. Okay, you know, really, even if there was a fire, it's no big deal. I'm a little cold anyway. It might be nice. We could roast some marshmallows. Now some people are covering their ears. You know, really, a burnt building creates jobs, right? all these chairs, we have to rebuild all this stuff. So maybe it's not the worst thing in the world. Still quite a few people looking to put it out. Okay, a whole group now stands up and says, we should really listen to the experts. Okay, well actually I'm an expert, somebody else stands up and says this, I am an expert and I know that there is absolutely no fire. So why risk it? Why would we want to let these burglars come in? Right? Why would we want to risk it? Keep in mind, you can change your answers. All right, a whole bunch of people agree. Yeah, definitely don't open the windows, don't do anything. We don't want these burglars coming in. And really, there's no fire. That's what the expert tells us. Really? Okay, here we go. So if there is a fire, there are in fact sprinklers in here, right? So if there is a fire, maybe we could just sit back and do nothing. Cover our ears, sing loudly, watch an amusement, whatever. We could just do nothing because the sprinklers are going to take care of it anyway. So that just takes care of this whole scenario. So one of the experts, so-called experts, says that they won't be activated soon enough. Maybe we should do something. A whole bunch of people now enter this conversation. The chair is already ruined back here. So there's a chair now that you know, kind of mysteriously is now ruined by this invisible fire. Okay, more people are now looking for a way to put it out. The damage is done. It's too late to do anything. Why bother? That chair was old and falling apart already. It's natural. I'm hungry. I hope the sprinklers don't ruin my hair. I wonder if anyone liked my Facebook post today. So I have to say, I can tell that you guys are a bunch of concerned citizens. Because you're still looking for a way to put the fire out. It did go down, but now it's gone back up. Okay, a few of you asking for more information. And I would say if we went through this scenario, and again, this is where doing a poll in front of a bunch of people, you never know quite what you're going to get. But what I suspect is that if we were going through this in an entirely different context, is that the bottom two bars probably would have gotten a little bit bigger. Right? People just deciding to totally and completely disengage, stop trying to figure out a way to put this out. So then we come to one more person that has something to say. And that's something that throughout all of this we may have forgotten about, and that's what if the fire is real, and what about the kids who are in the other room, who have no say in what happens? So based on your responses, I think that you guys probably figured this out given the context of today's conference. But this is a metaphor. There is in fact a fire. If there's not in the room, please don't run out. For climate change, right? So there's this weird thing that's going on. It's not something that people can really see or smell or whatever on a daily basis. The experts are telling us that it's there. Most people don't really understand it. They know it's an issue and they know it's something that should probably be addressed. Most people are concerned about it. I'll show you lots of graphs in just a little bit. But most people are in fact just covering their ears and singing loudly or sitting back and watching an amusement. Our building, anyone know what that's a metaphor for? We can't leave, right? We're stuck here. The sprinklers, maybe not quite as clear, natural carbon sinks, right? So there are natural ways that excess carbon in our atmosphere will be taken care of by our planet Earth. It's done it for a really long period of time, but it takes time to happen, right? So it may not happen in a meaningful time frame. The damaged chair, observed impacts, things that we've already seen happen. So I'm going to start, and what I'm going to do following the activity, and I'm going to refer back to that a few times, is I'm going to talk about some of the science, and I'm going to start it out here by a question that's posed to me quite often. The climate has always changed. People have adapted. What's so different now? It's natural climate variability. How is that different from anything else? So I'm going to talk about some of the science in answering this question. And then from there I'm going to talk a little bit about human activities and things that we've been doing or not doing to address climate change. And then I'll talk a little bit more specifically about some of the stuff that we've been doing at my home campus. So to address this question, the climate has always changed and people have adapted. What's so different now? This is a slide that I use a lot when I give presentations for the general public, and I thought it would be good for this group as well because while some of you are meteorology students and know quite a bit even about climate change, some of you maybe are not, and so I just want to make sure that we're all kind of on the same page. And whenever I give a talk out in public at like a town hall meeting or some sort of gathering, my students usually are saying, Dr. Hanrahan, don't show a graph. And my response is, well, I'm a scientist, I'm going to show a graph. And not only that, even though it's a graph and it's kind of complicated what you're looking at, people tend to get this piece. And this is the one slide that I show where people really kind of go, okay, I get it. I understand why this is different. So if you haven't seen this before, what we're looking at is our data from Antarctica. So if we drill down about 2 miles, we get this ice core, and we get all sorts of really great information from the ice core. So you go all the way down to the bottom of the ice core, and there's little bubbles, and the little bubbles contain samples of the atmosphere going back almost 1 million years. Almost 1 million years. So the time frame is unbelievable. And we can get some information about the atmosphere. Specifically what we can get is we can get information about greenhouse gases in our atmosphere. So specifically carbon dioxide. So we can get an idea of how much carbon dioxide has been in the atmosphere over about the last 1 million years or so. This one actually goes back 800,000 years. So if you look at the blue line on top, you can see that there's been some big fluctuations of carbon dioxide. And it ranges between about 180 and 280 parts per million. Parts per million, that's a way that we measure something that's called a trace gas. There's not very much of it in our atmosphere. So it's kind of like a percent. It's just instead out of 100, it's out of 1 million. Okay, so there's not very much of it. But just think about the numbers, ranging between about 180 and 280 parts per million. From these ice cores, we also get information about temperature, what we think the global climate temperature was at that time. And so that's the red line that you see below. And before I even line these up, you probably kind of did this in your head and said, wow, those really match up, right? So they're very well correlated. And as it turns out, that is the case, and we know that this is at least partially because carbon dioxide helps to regulate global temperatures. So when there's more carbon dioxide in our atmosphere, temperatures go up. It tends to keep energy closer to the surface of the Earth, kind of like a blanket, so the temperature underneath goes up. When there's less carbon dioxide in the atmosphere, global temperatures go down. As it turns out, though, that these cycles, these big fluctuations that you see here, are not, we don't think, driven by initially changes in atmospheric carbon dioxide, but instead changes in temperatures that occur from changes in the way that the Earth rotates around the sun and changes in Earth's tilt. So we have a pretty good idea of what it is that changes Earth's climate system over these particular timescales. So we have this fluctuation that lasts about 100,000 years. And it goes in between glacial periods, which are the blue arrows along the bottom, and interglacial periods, which we're living in today, which are the red arrows along the top. So I want to key in on just the last fluctuation. So about 20,000 years ago, we were at the end of the last ice age. So we were at the end of the last glacial period. And global temperatures were quite a bit colder than they are today. And in fact, there was a North American ice sheet, permanent ice, that came pretty much as far south as about Valparaiso University. So when I'm giving this talk in Vermont, it's a little bit easier because I say I went as far south as New York City, and so we were underneath like 2 miles of ice. I suppose it was maybe a little bit thinner here. But in the end, it was a very, very different climate system. Much of North America was covered by this permanent ice. So a very different climate system at that time. Carbon dioxide in our atmosphere at that time was about 190, the weird units, parts per million, but just 190 is the number I want you to stick in your head. Over a period of about 10,000 years, carbon dioxide and temperatures increased. And this line right here looks like it's pretty much vertical, but it's not. It actually took about 10,000 years for that climate shift to occur. And that equates to an increase in carbon dioxide of about 90 parts per million. About 90 parts per million over a period of about 10,000 years. So just keeping in mind that the difference between us being under at least some amount of permanent ice, right? So this permanent ice sheet coming really far south, at least around North America, and the climate system that we enjoy today is a difference of about 90 parts per million. So within about 150, 160 years, we have managed to put about 130 parts per million additional into our atmosphere. So we have more carbon now in our atmosphere than we have had for at least 1 million years Best guess right now is at least 3 million years. And we've managed to increase the amount of carbon by 130 parts per million in 160 years, which far surpasses what nature managed to do in a period of 10,000 years. And so thinking about the difference in these two climate systems between 190 parts per million and 280 parts per million, we are truly in a brand new climate system that humans have never seen. So you may be wondering where the red line is right now, right? So the blue dot here is just carbon dioxide. So where is the red line right now? And as it turns out, it's still sitting way down there. Can you guys see the little red dot down there? So it's still sitting way down there. And so a common question I get here is, well, what happened? Why aren't they following suit? Shouldn't the red line be right there with the blue line? And this is a very common skeptical argument that, well, carbon's been going up and temperature isn't going up the way that it should be. And there's a really simple answer to this. And that is this. If you take a loaf of bread and you put it in the oven, even preheat the oven maybe to 400 degrees, and you put this loaf of bread in the oven, are you going to take it out 2 minutes later and it's nice and toasty, 400 degrees? No, you're probably going to leave it in there for maybe a half hour, maybe an hour, right? So even though the oven is set at 400 degrees, it doesn't mean that that loaf of bread is going to be 400 degrees right away. It takes time. It takes time. And we can think about our Earth as being a really, really big loaf of bread. So what we've done is we've turned the setting way up on our climate system, and now we're just waiting for global temperatures to go up. Not only have we turned it up, but we continue to turn it up every single year because we are adding huge amounts of carbon to our atmosphere every single day. And we do this by just lighting our buildings, driving our cars. When I flew here yesterday, all of these things, when we're burning fossil fuels, coal, oil, natural gas, we're pumping huge amounts of carbon into the atmosphere. And this is carbon that's been stored beneath the surface of the Earth for tens, hundreds of millions of years, very long periods of time. Okay, so in terms of expected impacts of climate change, and again, I'm just kind of doing a climate change 101 for those of you who don't have this background. Climate experts are not concerned about a couple of degrees of temperature increase of our planet. That's not what we're concerned about, right? Because if the temperature in this room increased by 1 or 2 degrees Celsius, none of us would probably even notice. But what we're concerned about is that the Earth is so incredibly huge that that little teeny tiny temperature increase is a massive increase in energy. The energy is what we're concerned about. So the expected impacts, and this is all theory, this is what theory tells us, the expected impacts of climate change, of having additional energy in our climate system, of course warmer temperatures. This isn't even, it doesn't mean we're going to warm year after year after year. It doesn't mean that every place is going to warm. So we know that the northern latitudes are going to warm quicker, say, than the equator. We also know land is going to warm quicker than the ocean. Heavier rainfall, which is going to result in flooding. And this is actually much more complicated than just this. It's thinking about our hydrologic system kind of on steroids. I like to think of our atmosphere as like a whole bunch of buckets. We have buckets that can scoop up water from the ocean, from our lakes, from our rivers, carry it downwind. So in North America, it's carrying it across with the westerlies and then dumps it somewhere downwind. And the idea here is that when we have a warmer climate system, when our atmosphere is warmer, what happens is that bucket is getting bigger and bigger and bigger. And so it can pick up more water at any given time, but that also means it can dump more at any given time. So when it rains a lot. But at the same time, we have longer stretches where there is no rain. That's because the atmosphere is busy picking up all that moisture. So in addition, kind of counterintuitively, we have this flooding that's resulting from tons of rain, but we're also going to have regions that are going to be much drier. Some areas are actually going to see both. So in my home state of Vermont, we're actually seeing longer stretches where we don't have rain, but then when it rains a lot. So it just changes in those precipitation patterns. More wildfires. Again, theory tells us you have more drought, you have higher temperatures, we're going to have more wildfires. More extreme weather. You combine extra water vapor in the atmosphere with warming near the surface of the Earth. The meteorologists in the room know that that means instability. That feeds into climate, or that feeds into weather systems. So we know that we're going to have not only more extreme weather, but more highly variable weather. So really big swings from one to another, and less predictability. Studies are now starting to show that it's going to become harder and harder to forecast extreme weather events. melting sea and land ice. We know that the Arctic is warming faster than pretty much any place else on the planet. So as a result, melting sea ice changes albedo, so we have more energy that's coming in from the sun. Land ice melts, that results in sea level rise, also flooding. All right, so this is what theory tells us. You do a quick Google search and you type weather, severe weather, or something like that, forest fires, whatever you want to type in, and you're going to get hundreds of results. And so what's happening now is that we are in fact in this brand new climate system, and we are starting to see these theoretical impacts. So we're starting to see really, really warm temperatures. We're seeing, of course, we still do get record cold temperatures. It's just that we're seeing a lot more record warm temperatures than the cold ones. We're seeing just kind of some weird, strange storms. And as an atmospheric scientist, I tell my students, my meteorology students who are what we call weather weenies, I don't know if you call them here too, but they're like, I've loved weather since I was 3 years old. I don't like that climate stuff. I like severe weather. I say, if you like severe weather, you like climate change, because this is the most interesting stuff you are ever going to study, right? These are storms that humans have never seen. This is essentially what we're walking into. We're seeing more and more wildfires. The overturning of our ocean. This is a slide that I just added a few days ago. Some studies just came out that are now showing that the overturning of our ocean is slower than it's been for at least 1,000 years. And again, this is a projected impact of climate change because we have this freshwater injection primarily off of Greenland. And this is something that was forecasted to happen maybe by about the year 2100 by our climate model. So we think it's starting to happen now. If you're not directly impacted by weather, you're probably indirectly impacted by these changes to weather patterns. If you're in northern latitudes and you eat fruits and vegetables during the winter months, you're probably getting it from a southern location. And a lot of those southern locations are largely being impacted by changes in weather patterns. There's some areas, because of this change in our water cycle, there's some areas that are literally running out of water. And the reasons for that are complicated, but climate change absolutely plays a role. So for example, a town in South Africa, Cape Town, they're about to run out of water. It's a city of over 3 million people. It's a very modern city, and these people need to go somewhere. Okay, I want to come back to our metaphor, our activity that we started with in the beginning, and talk about all of us. So all of us in the room, all of the characters that I have portrayed here up on the screen, really just represent all of us. So kind of this bickering that's going on right now with the science of climate change. So I'm going to start by talking about scientists' perspective on the science of climate change. So when I first started studying climate change, which was probably about 13 years ago, I was struck by the level of agreement about the basic ideas of climate change when I went to conferences. And so what I found is that, and this is coming from the American Meteorological Society position on climate change, but you could pull these statements from any major scientific organization. They all say the same thing. So I'm just pulling from one organization. So we know that the warming of the climate system is unequivocal. We know our planet is warming up. If you look at the graph in the upper right-hand side, these are global temperatures. It's been above average compared to the 20th century average for my entire life, and definitely most of yours. So temperatures are steadily marching upward. That piece is put to rest. We know that that is the case. The other thing that is also put to rest, and this is something that surprises a lot of people, is that the primary cause of these increases in temperatures agree with theory. We're pumping all this extra carbon dioxide in the atmosphere. You guys saw the graph. It makes sense that global temperatures are going up. If they weren't, we'd be shaking our heads and scratching our heads and trying to figure out why. So we now know that most of climate variability is directly attributed to humans, and that most of the warming we've seen since the 50s is also caused by humans. This is based on a large and persuasive body of research. Scientists agree about this. So again, when I started traveling to conferences, I started reading research papers. What surprised me is that I never once went to a talk where somebody stood up and said climate change is real. And the reason for that, I mean, it's the same reason why somebody doesn't stand up and say gravity is real. Because yeah, we're like, yeah, duh, we all know that. And so when you go to a conference with a bunch of climate scientists, nobody is saying that climate change is real or that humans are the cause, because we just know that. We're now trying to figure out all the little details. So how much is extreme rainfall going to change in the Midwest or in different regions? These are all the little tiny pieces that we're trying to figure out now. But these two main ideas are settled. We can do something about it, but we need to do it quick. So mitigation, well, we need to think about stopping putting carbon in the atmosphere and then ultimately getting it back out. So mitigation will reduce the amount of future climate change. It'll reduce it, we can't stop it. And the risks of impacts that are potentially large and dangerous. And they do go on to say, but we need to hurry up and do it now. Okay, so we can do something about it. So if we counter this with America's position on climate change. So when I say America, what I'm talking about is, of course, climatologists can be Americans, but we're a very, very, very small fraction of Americans. So really, this is just kind of getting an idea of what non-climate scientists are thinking. So 70% of people think that global warming is happening. This is awesome. And I say this because this number has been really low. It was like 50% just maybe a few years ago. And so I think that the record warm years of 2014, 15, and 16 really woke people up. And so now people are saying, okay, yeah, we think something is happening. But I think it's natural. So only about half of people think that humans are the cause. And this is concerning because in my mind, the best thing about climate change is that we are the cause. That is the best thing because that means that we have our foot on the gas pedal and that means that we can start to back off. And we know exactly what the problem is. I'm not saying it's easy to solve, but we know how to solve it, right? If the sun were getting bigger or something like that, that would be a lot harder to solve. This problem is manageable. We just need to decide that we're going to do it. Only 13% of people understand that climate scientists agree about this. Several studies have been done that show that there's at least a 90, possibly a 97%, maybe even higher consensus among climate scientists. And anecdotally, that's been my experience as well. So people don't even know, there's so much bickering going on that people don't even understand that we agree about this. And this is the number that is, I think, probably the most alarming. And that is that so many people are so busy covering their ears and singing loudly or just sitting back and watching an amusement, or maybe some people are asking questions that we've just kind of gone, okay, we're not going to be able to do anything about this. 7% of people think that we can actually do something about this. That's an issue. So you might be wondering where people are getting their information then about climate change. And so broadcast news is a good place to start. But if you take a look at how much time was spent talking about climate change in all of the year 2017, which was a second or third record warm year, depending on if you ask NASA or NOAA, about an hour was spent talking about climate change. So you might even think, well, wow, that's not too bad. When I saw this number, I thought, wow, that's not too bad. That's higher than it's been in the past. But then you realize that almost all of it was not talking about what we will do about climate change or connecting catastrophic events to climate change, but instead talking about what the Trump administration thinks about climate change. So it's basically just not being covered in broadcast media. So social media, for better or for worse, about 2/3 of US adults get their news from social media. So it seems like a good place to be, especially when you think about the fact that Facebook, which leads here, has 162 million US adults on Facebook, right? So that's potentially a huge audience that we could reach with correct information about climate change. And just for perspective, that's more than the number of US adults that voted in the last presidential election. That's a lot of people that we could be talking to. But the problem is that everybody is putting information out there about climate change. So we have experts that are doing it. We also have non-experts that are doing it. And people that maybe have ulterior agendas that are doing this. So is the climate actually warming up, or is it some big hoax that climate scientists came up with, right? It's really hard to tell the difference between those two. And I would argue that this type of article is much easier to understand for the general public. And the reason why it's easier to understand is because they can write it any way that they want. If they're not writing about the actual science, they can write it in such a way that's really easy to understand and easily digestible by the general public. Writing about the actual science is hard. It's hard to write about, it's hard to understand. So oftentimes people end up going to stuff like this because it's just easier for them to understand, even though it's not scientifically correct. Going back to our analogy, and this is the part that I think is the most important, that I know is the most important, is the kids in the other room. Because of course, this is today's children and future generations. And part of the reason why I speak at events like this and why I've been talking, I should say the reason why I speak at events like this and in other events where I'm talking to the general public is because I am now personally invested in this, because one of those kids in the other room is my own son, and he's 3 years old right now. So for me, as a scientist, I used to just be really focused on the research. And I thought it was really interesting, a super interesting scientific problem, something that needed to be solved, something that needed to be understood. And then when I had a kid, my whole perspective changed. And this is the reason for that. So, I'm sorry, another graph. I am a scientist at that. So here's a graph from the IPCC report, the last IPCC report. On the far left-hand side, that black line is global temperatures. So we're starting out in the mid-1850s, and we can see that there's like a little slight uptick towards the end there. And then we get to just after the year 2000, and just for reference, because this is an older figure, so I just want to show you where we are today. So we're just at the very beginning of this. So oftentimes when I show all those graphics with the news articles coming up with the forest fires and storms and all of that stuff, people are really surprised to hear me say that what you're looking at is not climate change. That's analogous to saying that that chair in the back of the room is a structure fire. We are not looking at climate change. What we are seeing is the very, very, very beginning of climate change. So what kids will see, what a lot of you will see as students, is you're going to see a very different climate system than what we have seen, some of the older people in the room. So moving forward, if we continue doing what we're doing, if we keep bickering about this and we decide that it's hopeless and there's nothing we can do, the chair is already burned, it's hopeless, then kids are going to march right into this. So when it comes to future climate scenarios, the biggest unknown is not atmospheric dynamics, it's not our understanding of radiative forcing, it's not our climate models, it's what people will do. That is the biggest unknown. Will people continue to just pump carbon into the atmosphere, or will we get our act together and decide to do something about it, stop putting it in the atmosphere, and then ultimately figure out a way to get it out, which right now we don't have the technology to do that. So if we keep doing what we're doing today, reopening coal plants, moving away from renewables, we're marching right along this red line that you can see along the top. This is exactly where we are headed. So again, I've seen this graph several times, and this is a graph I had seen before I became a mother when I suddenly did the math, and I realized that this dot right here is when my son will be in his 80s. And the impacts that we expect to see are not going to happen in the year 2100. They're going to happen up until 2100 as well. And so if we think that everything that we've seen is a different climate system, and wow, we should really watch out for climate change, we've got to keep in mind that we're talking about this little teeny tiny uptick compared to what the next generation will see. So looking at the temperature, again, on the left-hand side, you might think 4 degrees Celsius, big deal. Here's our best guess of what we think all of this extra energy in our climate system might do. So this figure is from the AR4 IPCC report, so it came out in 2007, it's a little bit older, so I put a line on there for where we were at for 2017. Just before the 1 degree mark. We're already seeing decreasing water availability, more drought, more water stress, wildfires, various invasive species are moving around, and just species in general are moving around. More floods, storms, damage from heat waves, floods, droughts. So we're already seeing all of these things. That was those news articles that I pulled up before. Moving forward, by the time we get to 2 or 3 degrees, 2 degrees will probably be there within the next couple of decades. Here we're showing an overturning or potential weakening of the overturning of the ocean, which, as I said, is already starting to happen. So a lot of these things, a lot of it plays into ice dynamics that our models have not handled very well. A lot of these things are starting to happen quicker than we had anticipated. If we move on to 4 degrees, again, this is taking a look at when my son is in his 80s, and this is something that a lot of you will probably see as well. We're looking at least 40% of extinction of all species on this planet. And this is because our climate system, yeah, it's changed before. Absolutely, our climate system has changed before. But right now, it is changing faster than any other climate shifts that we know of. And it's irreversible. There's nothing that we can do about it. It can't be undone in a meaningful time frame. So in terms of people who are concerned about this, people are in fact concerned. So it's not like we're just a bunch of cold individuals that don't care about our kids. People do care about this. So this is a recent study that was done in 2016. The red on this map shows the percentage of people who care a great or moderate amount about future generations. So people do in fact care. People are concerned. And so you might think, well, they're concerned about it. They're trying to figure something out. They're asking questions about it. They're trying to do something. They're trying to put that fire out. But then if you ask those same adults, do you discuss global warming at least occasionally? The red on this map shows the people who discuss it at least occasionally. There's no red on here at all. Nobody's even talking about this. This is potentially the biggest issue, the biggest problem that humans have faced, and we're not even talking about it. We need climate scientists talking to politicians, talking to our elected officials, talking to economists, and right now nobody is talking about it. Even climate scientists. We are sitting in our own little bubble. We've done it for a really long time, and in my mind that's one of the reasons why there's this huge discrepancy between the understanding of climate change science. The state of it is because climate scientists aren't talking to the general public. Because quite frankly, it's hard to do and it's frustrating. And so a lot of us aren't doing it. We go to our own conferences, we publish in our peer-reviewed literature, but then we just stay right there and we don't reach out to the public. So moving forward, again, as I said, the biggest unknown right now is what people will do. On the left-hand side, these are temperatures again, degrees Celsius, and you can see the numbers on the right-hand side. On the left-hand side is mitigation. This is where we get our act together today, and we figure out a way to minimize our emissions. We get them down to zero, and then start pulling carbon back out of the atmosphere by about the year 2050. On the right-hand side, we just throw our arms up and we say, well, the chair is already burnt, it's already done, there's nothing we can do. Because that's another thing I hear a lot from the general public and also my students, is that they feel like, well, it's already been done, the damage has been done, there's nothing else we can do. And what I argue is that, no, there's so much more damage that is being done right now, and we need to hurry up and do something about it. So the left-hand side is a climate system that is in fact different than the one that we live in today, and much different from the one that we lived in maybe 50 years ago. But it's one to which many species can adapt, most species can adapt. The one on the right-hand side is much, much different. Okay, so this is actually a picture of my little boy on a lake in Vermont. And the question that I ask now is no longer what can we do, but what must we do? We cannot forget about the kids that are in the other room, that have no say in what we're doing. They're going to be stuck with this disaster that we've caused, and we're no longer going to be around to save them. So we can't be thinking about it in terms of, can we do something? We need to be thinking about what will we do, what must we do? And my answer to this right now, it used to be, well, use, reusable water bottles, or don't drive as much, or, all of those things. Yes, do those too. But right now, what I'm asking you guys to do is just start talking about it. This is what we need to do. It needs to become part of our conversation. Because if we're not even talking about it, we are never going to get anywhere close to a solution to this problem. So I'm going to talk just very briefly about some of the work that we've been doing at Lyndon. And so this starts with a small group. It's called the Climate Change Communication Group. I had two students two of the students are pictured here, Ariana and Kayla, had come into my office the year 2014. I had just become a mom. I just started in my tenure track position. I was really busy with research and teaching and everything else. I already felt overloaded, and they came in and they said, Dr. Hanrahan, we want to start getting into local schools and start talking to the public about climate change. And I just kind of went, no, I don't want to do that, because it's hard to do, and it was something else on my plate. And probably not coincidentally that, I had just had my son, I decided that this is something that I really need to do. It was something that was important. It was something I needed to prioritize. And so we went ahead and we started the group, and Allison, I don't know where she ended up, but she's, okay, right back there. She's actually pictured in here. So she was one of our first members all the way back in 2014. She's now a graduate student. She's got her master's degree at Purdue. And so she has moved on to bigger and better things, but our group has also really grown. And so all it took was two students coming into my office saying, hey, we want to do this. And all of a sudden, within just 4 years, this group has grown so much. We've gone on to do so many things. So we go into schools and we talk about it. We hold events at the college. We hold public events. I held my first public lecture ever, which was very interesting to say the least. We go to town hall meetings where now the scientists in the room and they welcome us. We've started doing a little bit more in terms of like actual activism. So participating in climate marches. We've been getting some press, so it means that our message is stretching, further and further, which is fabulous. And I think that this outreach piece is so important for a few reasons. First of all, of course, we're getting the message out. We're letting people know, hey, we are scientists. As soon as you say that you have the credentials, people listen. Most people are uncertain about climate change. Most people will listen, and they want to have that expert in the room. But in addition to that, what I've learned personally is that being a mentor for my students and showing them that this is a priority and that this is something that scientists should do, they are now starting to accept the responsibility to engage. They're starting to accept that responsibility to instill a sense of urgency, which is something we haven't done before. So I think right now, young people, young scientists, it's really a perfect place to be in terms of starting this outreach. And this is one of the reasons why this is so important, because we are up against a lot. So this is a mailing that went out to over 350,000 science educators. Did anybody in this room receive this? How many science educators we have in here? Nobody. Okay. You did. Okay.
Oh, yeah.
So yeah, and I got one, and my colleague got one, and a whole bunch of people got one. Okay, so what this is a mailing by the Heartland Institute, and I won't go into the Heartland Institute right now, but essentially what it is this super thin book and this movie that cherry picks a bunch of data trying to counter the results of thousands of scientific papers. And they sent this out to over 350,000 science educators, mostly K through 12. Think about just the cost associated with that. And really, if you flip through this, and as a scientist at any stage of your career, you're going to flip through this and say, this is junk. Because the graphs are blurry, it's not written very well. So it really is trash, but at the same time, when you have that wide of a reach, you potentially have an impact, right? So we're up against this. There's a lot of work to do. My response to this, by the way, is to create a social media post. My social media page has completely shifted. My friends and family probably hate me. I no longer post pictures of my son, because what I learned very quickly is that you can't be a climate scientist talking about climate change while also posting pictures of your family. So it can be a very difficult decision to make sometimes to start doing this. But to me, I decided that it was worth it to not be able to share pictures of my son on social media if I'm going to start speaking out about climate change. And I even got 62 shares on this. I don't even have that many friends on Facebook, so that was pretty good for me. So you figure this sort of thing, this message can reach pretty widely. And so we are pretty much out of time, but what I do want to do is just take maybe a minute, if we have it, 2 even maybe, and pull your phones back out. And this is your opportunity to just share with us, if you have something in mind, just how you'll start the climate change conversation, whether it's here, whether it's when you go back home, whether it's when you're sitting at the dinner table with your uncle who always counters all the science of climate change, whatever it happens to be. If we could just share some ideas of what you might want to do to start the climate change conversation. Let's see who's going to be the first. Everyone's typing, so we're going to have a bunch pop up here. So, oh good, okay, so ask the question, what do you know about climate change? Show my dad some graphs, I love that. Parents, it's funny because my students, I teach them all about thermodynamics, all these things in the classroom, then they go home over break and they say, yeah, my dad told me that climate change is fake. Can you imagine if they did that with algebra? It's just so weird that they just say that it's not real. Okay, so questions, what do you think about climate change? Talk to my grandparents, okay? Talk about it with family. Family really can be the hardest thing to do. And even asking your family, what do you know about climate change? I think. Talk about climate change a lot more, or just start talking about it, because a lot of us don't talk about it at all. In the engineering workplace, yes, we need engineers. We really need engineers. This is a huge engineering problem. Share the YouTube of this talk. Okay, it's going to be on YouTube. Cool, I made it. Use Facebook. Yeah, Facebook, people laugh and they say, well, you're going to be in your bubble. But, we're in our bubbles, but we have all those friends from high school. We have a whole bunch of people who have very different views from us. And our family like to read our posts, so it's a really good way to communicate. Respond and counter with comprehensible materials when people share incorrect. Yes, so we have to counter the incorrect stuff. Talk about it with friends and family. Start with family. Yes, yes, yes. Spread the word to those close to you. I've already started and I'm running for state rep to try to make a change. Yay, who is that? Oh, congratulations. Thank you. Talk about facts. Make it part of an everyday conversation. Yes, at church, absolutely. Talk about it. Encourage students to organize around this issue. Yes, definitely. And students want to be involved. We started with a teeny tiny group and most of the students in our department went, what are you doing? I don't want to do that. Now everybody wants to go. We had 27 people who went down to DC for the People's Climate March. Talk more about it overall. Use reusable water bottles. Yes. More outreach about climate change through the university, events, talks, presentations. Yes, start our own elementary, middle school education group. All right, cool. Talk to friends about climate change. Stop watching Fox, yeah. Public interactions to inform strangers of scientific reality. This is great. More vocal and detailed about the reasons behind my green actions, using less plastic, driving less. Yes, I know, just even thinking about it. Even my 3-year-old son will be like, Mom, are you done in that room? Turn off the light. You know, so it's just, he's even really good about just reminding me of these things, because sometimes it can be hard to do. Don't ignore the facts anymore. Remind people in my church that we have a responsibility to protect God's creation. Yes, there's some really good books out there, too, about that. And protest or activist events, vote for the state rep, yes. Dress it, okay, good. Oh, this is awesome. I can tell that you guys are more mature. I did this with some middle school students like a couple weeks ago, and yeah, I had to turn it off pretty quickly. Okay, this is excellent. So if you want to keep typing these in, I can save all of these, so if you want them to be available somewhere, then I can do that.